आशा की आवाज आ रही है? Good to all. Today we are here to understand the thermal metrology, how we used to do the calibration of thermometers, and nowadays we are having infrared thermometers. And I remember at the time of this COVID-19, we were facing the problem of these infrared thermometers, and at the time, National Physical Laboratory came out, supported the country, supported the nation by doing the testing and calibration of these infrared thermometers, which were entering or importing into the country. So we have with us Dr. D. Shivagun. We have with us Shri B.N. Dixit, Director, Legal Metrology, Government of India. As we are all aware, that Shri B.N. Dixit Saab is always with us for supporting us, the legal metrology by all the means which he can. He is here to support us. He is here to let us know what are the new changes going on in the legal metrology. Sir, I would like to request you kindly speak towards and inaugurate our workshop of today. Shri B.N. Dixit, sir, please.
Thank you, Ashutosh ji. And
Thank you, sir.
today is a very good conference. And you know that during the COVID time, this infrared thermometer, how it is helped the common people as well as the hospitals and the many public places, including the offices and schools, to measure the temperature and all that very things. The facility for testing of these very thermometers was mainly available in the National Physical Laboratory, and on the basis of that, we were issuing the certificate, and which were helpful to the manufacturer as well as to the importers. So, like that, we are facing the every day the new challenges. We do not know that tomorrow what challenges will come before us, and we have to ready with our technology and the thoughts and process. That certainly we have to face some challenges, and we do not know that what is the subject. So, in that respect, all the laboratories should be prepared, whatever the facility they have, and plus they must have some visions that what they can also do for the society uh, from that very laboratory. So this would be the initiative and thought of the laboratory, that how we can progress and help the societies. Because when we are opening any such organization, our government has opened such organization, it does not mean that it is only for the some particular purpose. Now these days, all the thing is meant for the whole nations. Wherever its best contribution is there, there these facilities may be utilized. So the challenges of this infrared thermometer was one of the example with us, and that we had taken challenge of that. And Sri Ashutosh Agarwal, Deputy Director, was one of the most contributor to facilitate the peoples with the help of National Physical Laboratory, and he has organized such programs. I think this is very good programs, and I wish for the success of this very program. I hope that the industry will be benefited, state government will be benefited, and whatever the other type of peoples who are attached with us, they will be also benefited. Thank you, Ashutosh ji. Thank you, scientists from NPL and state government legal metrology officers and the other dignitaries. Thank you, sir.
Thank you very much, sir. Thank you for your kind words. Certainly, you are always a ray of hope in the field of legal metrology. we always look towards you for the betterment in the field of legal metrology. Sir, as I already told you, we have today with us Dr. D. Shivagun Sahab, who is a renowned scientist in the field of thermal, temperature, humidity, meteorology, not only in India, at the international level. Presently, he is working in National Physical Laboratory, and his focus is on R&D activities. And basically, I think he's working on realization of Boltzmann constant, which is very important after this 2019 when we started. All these units have to be used with the natural constants in place of having the artifacts. Now we are having all these units realized from the natural constants. He is working on Boltzmann constant, which is very important for the country. And if there is any help required from the legal methodology side, we are always available. We are always ready to support. We are always ready to help you out, sir. For the on base for the new Kelvin unit, metal carbon unitic fixed points for thermocouple and radiation thermometry up to 3000 degrees Celsius, which he's working now. He is actually concerned with the standardization of IR clinical thermometry and how it will be done, as we are all aware, because in case of thermometers, clinical trials are very important, but in India we are not going towards the clinical trials. We basically do the laboratory testings, and on the basis of the laboratory testings we used to generally approve and allow the medical equipments in the country. I hope that sooner or later, with the help of National Physical Laboratory, we will also be in a position to do the clinical technology, clinical testing of these thermometers, blood pressure meters, and other type of medical equipments, and how they actually affect, how they actually show the readings, show the observations for the patients in India. We have to see. I hope that this particular conference will be very important, workshop will be very important for those laboratory people who are working in the field of thermal, humidity, etc. Sir, I would like to request you, you please kindly enlighten us about this new, very interesting, but the complicated subject which is related with thermal and the humidity. Sir, please.
Thank you, sir. Thank you very much for very kind introduction. And as respected Dixit sir has told, we have to be always ready with the evolving needs because we don't know what is going to happen. And in that contribution, CSR NPL, NMI of India, and legal metrology is always working very strongly and sustainably to serve the nation. So at the outset, I extend my warm welcomes to all participants in this today's workshop. And at the outset, personally, I thank Dixit sir, Ashutosh sir for inviting me to give this talk. And we are ready to share all the information. Whenever you have opportunity, kindly visit NPL so that we can show you what legal metrology and we jointly could serve the nation. So now I'll share my slides and I'll go through. Kindly, Ashutosh sir has given me 1.5 hours at least. So I'll try to utilize that opportunity here. So today I'm going to talk about recent advances in temperature, humidity, and moisture meteorology. And particular emphasis will be on measurement uncertainty in these various parameters. Of course, whatever I'm going to show you today is the very innovative contribution of my colleagues, Minaji, Gaurav Gupta, Komal Bapnaji, and my research scholars. So by acknowledging them, I will start my presentation. So whenever our laboratory peoples are working on these measurements, they're very afraid about little mathematics, but please don't worry. So metrology is the science of measurement. It is the measurement that makes science more scientific and not maths. Maths is the tool that we use, say, for measurement uncertainty and other parameters. So go very particularly in all the associated parameters and how they are affecting our final measurement uncertainties and the report of the results. So that focus we should do. Anyway, whenever we deal with any problem, say for example this COVID, but 100 years before also we had something catastrophic at that time, but that time the facilities were not enough so that we can understand what is happening. So it was very imperceptible. Anything that happens, as sir has told, so maybe it is imperceptible. But if you design the experiment, make the measurement, analyze, quantize, your understanding, familiarity about that problem becomes very, very vast as you go along. So measurement is the key to understand the world around us. And now, as you can see, we can now control the genome. We can see what kind of receptacles are possible with different evolving viruses, or that matter any scientific innovation that happens. So we need to have the measurement to be very, very crucial. So we are at National Metrology Institute, and our role is stated very categorically to develop the national standards. We are the custodians of the national standard. So what we do in the measurement is quantitative comparison of unknown quantity with respect to the standard quantity. Okay, we do the measurements means we are comparing the unknown quantity DUC with respect to some standard, and it is our responsibility to define, realize this standard quantity. What is 1 kilogram? What is 1 Kelvin? And so many other parameters. So we do this by international linkages. We have international standards. Then NMI is responsible to realize them in that economy and provide the calibration to the down layers. And wherever we have the calibration chain, it should be always continuous calibration chain, so that we establish the SI unit down to the user end. So what happens after the measurement is we may get some kind of a systematic error which we can correct for. Maybe we are a little confident, but many are the case we see that they are random in nature. Means our probability of finding true answer with reference to the mean is quite wide. So this qualitatively describes how the measurement setup is, how our measurements are. Okay, so we need to carefully address all the measurements should be associated with the measurement uncertainty whenever we report the results. So as everybody knows that all the measurement standards SI units are taken care by BIPM, and it is the world agency. All the signatory MRI signatory member nations are representing their countries in BIPM and disseminating that facilities measurement in particular in nation or economy. So this is, with this emphasis, this ASR was founded, and we recently had the 75th year celebration. So it is a long standing contribution to a nation for about 75 years. And the main basis is the major ones and accepted everywhere. So all the measurements that are performed here through the international intercomparison and linkages, they are accepted worldwide. Even our previous director, Aswal Saab, was very, very enthusiastic about the national quality infrastructure, how all these agencies work in a very coherent way, so that all our measurements and processes are accepted worldwide. Our products and processes have no trade barriers. So he has very well described that concept in quality infrastructure of India and its importance for inclusive national growth. So one can go through this 15-20 page paper, and you can see that it is very well described there. So essentially what we need for quality infrastructure is metrology, accreditation and standard. So Metrology is institute, say NMI level responsibility. Sorry, I have a sore throat today. So accreditation, we have under QCI several organizations for us, which is NABL. And for standards, we have BIS, and we also have the legal metrology enforcement. So with this, we can serve our nation's requirement in a very, very apex manner. So as Sir has told, a very advanced decision was taken after the about 10 years research that we need to redefine this SI unit based on the fundamental constant. Say, for example, it is a kilogram. It is one international prototype in BIPM France, and then copies of that are provided to each mRNA. Say for India, it is NPK. Okay, so when all these NPKs will go to IPK for periodic recalibration. So what was observed by scientists that each time they go for a calibration, they have to say clean. So adsorbents little bit are deposited on it, maybe in a nanogram level or microgram level. But after measurement, you wash it. I mean, you clean it. Then it was observed that some mass was lost. maybe nanogram, microgram, but that affects a lot to the meteorologists. Similarly, say for Kelvin, the Kelvin was defined based on a water triple point. So, however, pure substance that we have, even H2O is made of one H1, one H2, one H3. So that isotopic concentration does not allow us to go very fine below, say, about 35 microkelvin. So people said that these are either direct artifacts or quasi artifacts, and they need to be replaced with a very fundamental constant. These are inherent in nature and will not change for a quite long time from now. So with this aim, this redefinition happened, and you can go to ninth edition of SI if you are referring to many other things. So there are all definitions, their implications are very well described. So like for Kelvin, the definition is the SI unit of thermodynamic temperature, because what we are measuring now is the practical thermometry. So directly on absolute scale, we can go with the new definition, and it is defined by taking the fixed numerical value of Boltzmann constant. So Boltzmann constant value is fixed. So all in physics equations. So thermomechanical energy is directly proportional to K beta T. So when we measure the energy, K beta is fixed. You can directly measure the absolute temperature, thermodynamic temperature. So that's the beauty of the new revision, and every nation is going behind the establishment of these standards in their economies, and NPL India is also very proactively taking these programs to establish this facility. So the role is SI is there, NMI has to disseminate, realize that in that country or economy, and then provide the services to national calibration laboratories, and then they in turn will support all research or industries. So the MRA equivalency is, suppose one NMI is having the MRA signatory, then measurement performed at that NMI are accepted at the another NMI. Or similarly through accreditation bodies, if two accreditation bodies are mutually recognized by MRA, so all the measurement certificates provided by that accreditation body are accepted at the other. So it is worldwide acceptance for the measurement that you perform in your country or in your accreditation body. So this way we can have the measurement science conformity assessment and to the uses up to even industrial level, so that we become very confident and our product and processes accepted. They don't have any trade barriers. So now I will come towards the temperature standard. These are the staff that we are working with, and I request you to visit. Sorry, there is some distortion here, but it is the measurement traceability for temperature standard. So SI unit is Kelvin. Then we define this Kelvin because the major aspect regarding Kelvin is it is intrinsic property. It is not additive property. So we have to go to that temperature and measure, realize, disseminate, and the because of that the measurement uncertainties and the deviations are propagating from triple point of water, which is the definition of Kelvin until now. And through this we can realize say ITS 90 or provisional low temperature scale. But in India we have the facility from minus 197 degrees Celsius to even 3000 degrees Celsius. So with this we are serving our nation. So as I said the earlier, the choice was very fine, because as you can see the pressure temperature phase diagram of water. Now this is triple point is a very unique point. Little deviation in temperature or pressure will deviate that. So because of that robustness, uniqueness, it was defined at triple point of water. You know that absolute zero is there, where all the matter will cease, and then we have the open scale. So this need to be categorically realized. And as I said, TBW also has the several issues, because they concluded one international comparison between 2001 and 5, and they found that because of the isotopic content variation in hydrogen and oxygen, we were not all NMIs were not able to agree below 35 nano, 35 microkelvin. So that was the problem there. They decided that we should go for a material independent property, and Boltzmann constant is always there in all laws of physics, very fundamental constant, and with that we have decided to go for new Kelvin. So basically, it is a translational motion of the constituent particles. So how many joules of energy do this molecule possess at a particular temperature that resembles the temperature? So for say gaseous matter, it is three-dimensional. For say some thin film digester, it is two-dimensional. Some photonic material, it is one-dimensional. So it is amount of energy in joule per degree of freedom that corresponds to 1 Kelvin. So these fundamental statistical, mechanical, and thermodynamic principles were used to define and realization. So earlier the definition was on triple point of water, and realization was also always based on the triple point of water. If they make definition quite independent and they evolve various realization methods, then we can have a very robust measurement system. So for the efforts for new definition is of course we need to go from present triple point of water to the acoustic gas or any primary standard that they have described by CCT at BIPM. So in acoustic gas thermometry, this square of velocity of sound is directly proportional to thermodynamic temperature. So here in such a very fine resonator, a very high pure argon gas or monatomic gas helium will be placed, and then acoustic resonances will be measured. Those are proportional to temperature. But this gas is the matter property. So we need to measure at different pressures and go for a zero pressure. So in the new definition, earlier with respect to TPW, the temperature of TPW was defined and it was exact. Then whatever realization uncertainty was put on this measurement. So in the new thing, the value of Boltzmann constant is now fixed. It is exact, and triple point of water is a measurement quantity now. So whatever uncertainty that you measure on realization of K beta will be added on this triple point of water. As you know that in case of mass, it has already been decided, but triple point of water uncertainties are quite good. So CCT is not yet able to decide, and there are no many number of primary standards to have the international entry comparisons to make the decision. So the golden opportunity is that there is one layer added where we can have the direct thermodynamic measurement, primary standard, and the rest of the pattern will remain same as we were doing before. So as I said, this is the principle of acoustic gas thermometry. NIST is of course pioneer, but later LNE, NPL UK, they made very good progress, and they have defined the mechanism. Okay, with the acoustic gas thermometry, at present temperature you keep at triple point of water and measure K beta, see how much uncertainty is there, and then use that value of K beta which is defined already and realize any temperature. So we can go for even a relative method. You fix at say at triple point of water and measure any other temperature directly. You can measure the thermodynamic temperature rather than the practical thermometry. So this is the experiment that we have indigenously designed with our efforts, and with the support from one company in Mumbai, we could develop this. The surface roughness is about 32 nanometers, so that we get a very high quality factor for the measured acoustic and microwave parameters. So this is all verified by our dimensional standard, and with this we have a CSR project until 2024, and we hope to realize this within next 2 years or so. At least a proof of principle and some level of uncertainties. So as I said, then this will be a new primary standard, which is acoustic gas thermometry. And for high temperature, we are also going simultaneously for the radiation thermometry with metal carbonate at fixed point, so that from lower range to higher range, we can have a direct traceability to support our present measurements from -200 to 3000 degrees Celsius. So now we will come to temperature standards. What are the requirements and how this measurement uncertainties, CMCs are involved. Okay, so what essentially we need for thermal measurements is one thermal source, which is absolutely very stable. then sensors, one as a reference and another DUC that you want to measure, and both will be attached to some measurement device which should be very highly stable, okay, and should be characterized by the electrical metrology people. So with these, there are uncertainties associated with say source. They are mostly type B in nature, stability and uniformity. Because of sensor, we have the reported standard uncertainty, we have the drift. For platinum resistance thermometer, because it is not a standalone thermometer, we need to give the current to measure the resistance, okay. So this current will have I square joule heating, so those components are also important. And environmental condition, if we are using the read heads, and if they are affecting. So from the measurement device side, it is uncertainty of that unit which is reported. Then resolution is lot depending on the read head. So rounding and resolution and rounding of so very important. If you are measuring absolute in resistance, then uncertainty in resistance is also required. So that whatever reference or DUC there when first measured, we have to go for that ABC coefficients whatever are there. If those coefficients are properly evaluated with this fixed point calibration, then we can go for any comparison calibration that will also be then accurate. Okay, so these are the fixed point defined in ITS 90. You can see the metal luster in a graphite, and such a SPRT is used immersed in this fixed point so that we can make the measurement. For a radiation thermometer, there are black bodies and standard pyrometers, or earlier we had the tungsten strip lamp as a standard, and then black body. These were earlier traceable to PTB. Now we have established this facility up to 3000 with our own traceability. So these are the level of uncertainties at different temperatures, because as I said, we need to go to that temperature and realize. Therefore, at very intermittent temperature range, we have 17 fixed point defined for the this establishment of the state. So again, the TPW was very important. So critically, we have evaluated the measurement uncertainty. For this, you have to visit sometime how this state is being created. It's really very crucial experiment, and in a new way, because whenever we have to have the um, periodic or intermediate test to be carried out, you need to have the very fixed source. Okay, so either ice point or something you need to have in your laboratory so that you can estimate the drift. Okay, so platinum resistance thermometers are very good because they are very linear, but still you can see that at lower temperature they go for a debate temperature, means resistance will not linearly increase, and at high also they will have some losses. So their ITS 90 has given very standard equations how we have to interpolate. So basically you have to first time measure with the fixed point and evolve this alpha beta gamma coefficients. If you put that, then your measure temperature is very accurate. So these are the uncertainty components. These are mainly required for primary, but you can see that there are several parameters there. So for Boltzmann constant, we have again redefined this by measuring three TPW cells, and we could improve that level of uncertainty, which was in pill made cell, to now 0.08 millikelvin. So with the international linkages, we are sure that will be about 0.1 millik, so that we have the very good values of Boltzmann constant. So this is how whenever from room temperature you put this thermometer in a triple point of water cell, you see that at the triple point of water cell, its resistance remains absolutely constant. You take the measurement for many hours, and the measurement scatter is about 0.17. That was the data earlier. And as I said, this thermometer has the joule heating, so you can vary the current and know what is the heating effect, what is the rise in delta R. Based on that, you can calculate, because all those are very important when you are going to define the uncertainties of the level of say 0.1 or 0.17. Because this heating effect itself is about 1.7. So you need to correct it very carefully. So all the correction need to be placed, and then you evolve the uncertainty. So for fixed point, we need to have a very three-layer furnaces, and in that you put the fixed point. So metal will simultaneously melt or freeze, so that you get the measurement plateaus like this. This is melting. Melting is always influenced because you need to keep the furnace at high temperature. But in freezing, all the nucleation will be ceased, and you see that all the measurements are very very stable for a long time. So with this, you measure several fixed points, whatever range you choose, given in ITS 90. Say if you want to go up to 962, then you have to measure triple point, teen point, aluminum, silver, and after each fixed point you have to measure the triple point of water, because the Kelvin is made traceable by TPW. So these all drift and other parameters you need to be very very carefully calculate. And then because we measured at these black dots, say, but we need a temperature at say at each point 1 degree Celsius or 1 degree Celsius, then we have to have the interpolation. This SPRT is defined for the interpolation, the temperature between these two. So the uncertainties will define based on how much fixed point that we have taken into consider. More the fixed point, the accurate will be your measurement. So at your level, at the practical level, mostly digital thermometers with sensor are used. So there you have one as a reference and another as a device under calibration, and that is placed in a very highly stable dry block or water bath or uh, some oil. Okay, and that need to be very 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 stable. So the zeroth law of thermodynamics is the application. Okay, you have set the furnace temperature. Now this oil or bath will start heating. It will be in thermal equilibrium. Then these two sensors will be in thermal equilibrium with bath. Okay, then you said that temperature measured by reference is uh, as a reference, and whatever deviation you observed on DUC is very absolutely corrected. So this need to be very very highly stable. So if you want to have 0.1 degree Celsius calibration, definitely you need to have 0.03 as a path stability and uniformity. So that requirement is very very stringent, and with that you can definitely, if you get the millikelvin uncertainties for fixed point calibration, for comparison calibration you can go for 4 millik to 60 millik. So depending on the range, we can certify it with very very high levels. So there are also no, as I said, this enable health in specific criteria. They have given very categorically actually what no level of uncertainties, what are the parameters they need to be taken into account for the measurement. So as I said, if you have the range say up to 400 minus 50 to 400, if you measure more number of point, your dispersion within the point will be very very less. So deviation and uncertainties will be attributed very very accurately, so that the table that is generated between these points will be quite accurate. So you may have the sensor range which is very wide, but if your application is very for a typical range, we suggest you to measure more number of point in that typical useful range, so that you get the very less correction and uncertainties. So water bath is used up to 95, oil baths from minus 40 to 300, salt bath even one can go up to 550, and alcohol bath are being used up to even minus 90 degrees Celsius. So all these need some precautions like fume hoods for oil baths, and there is the worry for oil flash point, because after certain temperature the wafers itself will start burning. So those precautions you have to take into account before establishing the laboratory. Dry black, they can go up to 700 degrees Celsius. For thermocouple with a larger immersion, we can have up to even 1200 or higher. So heat pipe furnaces and low temperature, these are also quite a lot of opportunities. So we need to have the stability, which is the time dependent variation of temperature, and the uniformity, which is space dependent. In the given bath or calibrator, you put the thermometer at different locations and measure, it will give you uniformity. You put at one point and measure for say about 1 hour, so that will give a stability. But in many cases the length of the thermometers are not very very equal, in that case, enable and all other standard bodies also advise them to have the axial uniformity and radial uniformity. If they are loading many thermometers, then radial uniformity is also very accurate. One which is on the side corners or some place may not be in thermal equilibrium with the reference. Similarly, axial, we have observed that even you remove the thermometer by 1 centimeter or 2, it deviates 0.1, 0.2 degrees Celsius. So that because the losses from the top are quite heavily large. So those kind of care need to be taken. So such kind of stability you need to evolve for me. This is 36, so more than 1 hour. So you can see this is for a very large bath. I'm showing the data. So it is 0.5 millikelvin, and if you measure at the working range, working space that is available at different location, there are strategies which location to be chosen. So it goes up to 2 millikelvin. So always your stability will be very good, but your uniformity will be very poor because you are now running with the different locations. So all data is very historic, need to be very uh, peculiarly measured. So this is a very historic data by Madam Curie, and you can see all observations need to be very accurately attributed. So that is the fashion in this science. Another famous scientist who has this laser trapping of atoms, like for cesium quantum clock we have laser trapping, and then the temperature goes in microkelvin level, so that we can have the bunching of the atom. So these scientists are working on a low temperature physics for long time, and he developed the theories and made the experiment and got the uh, Nobel Prize. So all these are laboratory peoples who made the innovation and did very wonders in the development of science. So as sir has suggested, we should focus more on evaluation of measurement uncertainty. So it is how much we are dispersing from the mean value of that measurement. Okay, and if you want to understand more, the mainly the definitions and the understanding of each parameter. So you should download the GUM JCGM 100 2008. You should also look for a new versions always. And in NABL also, NABL 141, they are very illustrative for measurement uncertainty and specific criteria for each parameter. So I think earlier for thermal it was 124, quite good information was there, but now they have clubbed to 129. There also you have a very good information about measurement uncertainty and required parameters. Okay, so you identify what are the device under calibration requirements. So what is the range, uh, resolution and all other parameters. Then standard, depending on, you have to choose a standard which is very fine compared to that. Temperature source and measurement unit, you have to choose such that the level of uncertainty is easily achievable. And the combined uncertainty always we represent at the summation of root sum summation of type A and type B parameters. So type A is where you directly measure the statistical measured values, and type B are from the background. So the certificate given by somebody, or the stability that you have earlier evaluated, uniformity that you have earlier evaluated, immersion. So all drift also can be of standard, or DOC can also be attributed in type B. So all these will constitute to have the combined uncertainty. And then how much confident we are in that measurement. So there is one coverage factor. Okay. So when you go for a coverage factor, I'll come to that. So you need to have the different statistical distributions. Okay, so these are Ishikawa diagram. We say you make the homework. What is my measurement and what are the parameters involved in that? So from the source side, I said stability uniformity is there. From standard size, uncertainty of the calibration certificate that we have given from the reference, drift, resolution of indicator, because UC will also have separate indicator and its corresponding rounding of, and thermometry bridge if we are using for the very high level of measurements. So resolution uh, is very important when we are asking for, because we see very very different examples. People claim that we need to get very good uncertainties, but the required infrastructure at their end is very different. So there are different probability distribution functions. Don't worry about this. In temperature, dy by dx phenomena happens. If you change any parameter, correspondingly your other measurement parameter will vary. So we always use rectangle distribution for type B parameters, and for type A, of course, it is normal distribution in all case, whatever measurement you have. So all measurements, say suppose you measure the G. So I was teacher, so all students will get 980 centimeter per second square. And now since we are in the laboratory, we see that there can be different deviations. So this type of a budget we have to come out. So this is type A, which is I got from standard deviation. It is normal distribution, mean we'll divide by number of observables, which is n. So divide by say 10, you can come up out with 0.1. And the degree of freedom, because we say that this measurement is taken in a infinitely stable conditions. So all 10 measurements, suppose you take n measurement, then our degree of freedom becomes n minus 1, because so
I'm very sorry, sir. I hope I am observing that you are not actually, your health is not okay today. Even after we are putting a lot of pressure upon you to complete this 1.5 and about 2 hours on workshop. So my request is, how much time you can comfortably continue, please continue. Otherwise, we will do it in the next time. Not necessary that your health is very important for us.
time it is manageable.
Thank you, sir. Thank you. Please.
So we'll have n minus 1, because if you take out any one measurement, this mod of x minus x bar will go non-zero. Okay, so that way a reference thermometer, they will have some certified uncertainty. It is reported as k is equal to 2, so divided by k 2, you get the uh, standard uncertainty. Similarly, temperature indicator, also you have some uncertainty given. Drift of the thermometer, I will show the example. So if it is in ohm, you can take the this is for sensitivity. So 1 ohm change is equal to 10 degrees Celsius. If you have direct degree Celsius as a indicator output, then there is no issue. So for a drift, so you measured at 2020, you measured at 2021, and now so you take the difference of that value at 1 point, and whatever drift is there, you take it as a long-term drift. Uniformity of source, as I said, stability of source, as I said, or you can take it as a combine. Resolution, so it is d by 2. But if it is 0.01 degree thermometer, it is divided by 2 as the estimate, and then you put the rectangular distribution. Similarly, for rounding, if it is a 0.01 degree thermometer, logically it will round off at anywhere from 0.05 to 0.09. At 0.1, definitely it will display 0.1. Okay, so there are 0.5, 0.05, 0.06, 0.07, 0.08, and 9. So 5, so the average becomes 0.007. So this is the logic behind choosing the rounding of our parameters. In case of this glass thermometer, sometimes we take the uh, resolution even fine, because we can measure at very good thermal, sorry, the traveling microscopes and other things. So as I said, coverage factor up to take, you have to calculate by this method. So up to 10, you are about 2. So any parameter up to 2 is also having very good confidence. Mostly you will see that if you take the more readings, it will always come above 30, and the degree of freedom is always infinite. So you take infinite here, then all these uis upon infinite will become 0. So whatever you see uncertainty is there, you get the degree of freedom. So always you are confident, because when we go from one layer to another level of measurements, so we have to always compute the measurement uncertainty. So depending on these, depending on your requirement, you have to decide from which lab you have to take the measurement for your requirement. Okay. So if you go more down in the ladder, definitely, although they have the same infrastructure, the level of uncertainty will go on adding. Okay, so you become poor when you go to lower level of laboratories. So if you have apex level measurement, always go for top level. So glass thermometers are also very useful industrial and other applications. They come with very different list count. We cannot make one thermometer with a very small list count. Its height becomes very unmanageable. So they can have some accumulation chamber here, so that they can go for a larger ranges. And also for the safety, there is one accumulation layer at the top. So if you exceed the temperature, suppose you are measuring 200 and you are exceeding, unfortunately then this mercury will come and stay here. So it is the volume expansion. Okay, and the linearity of the measurement will depend on the linearity of this capillary. So this may vary depending on the temperature. So whenever you are measuring total thermometer, you should always measure in a total condition. Means it is, suppose you are measuring at 40, you have to immerse up to 40 degrees Celsius. If you are measuring at 60, you have to immerse up to that. If you are using the facility, because you need to have the certain depth of your bath, and most of the time I observed that they don't have this such adequate facility to immerse this depth of the liquid, and then end up with doing partial measurement. So if partial is doing, means your thermometer is largely exposed to the room temperature. So measurement taken at reference lab and the user lab may be different. So you need to compute the uh, stain correction. So that is the only difference. Many other points. There are such kind of gaps, air gaps, in dirt or interruptments. While movement, you see that this column breaks. So there are techniques you can make this join. So always observe before you start the measurements. So stem correction, because we note the thermal conductivity of this and the amount of thermometer dipped into bath and out of bath. So with that temperature difference out of the bath and within bath, you can take this as a stem correction. Okay, so for a very fine thermometer, this matters a lot. So always, so additional component for this will be stem correction. But if you use as per the fabrication or as per the advice, then you need not to take the stem correction into account. So therefore, another important industrial thermometer is thermocouple thermometer. Two dissimilar wires are joined. One is at the high temperature or low temperature, which is under measurement, and you need to have the reference, which is ice point. So the net potential difference generated between these two is directly proportional to the temperature difference, and you can measure that EMF here. Proportionately, you can put the coefficient, you can directly measure even in the temperature as well. So for thermocouple also we have very different range of fixed points at higher temperature, because its temperature range is quite high. Even for NPCIL or other nuclear requirement, we need to have the tungsten based thermometer, which is at even 2500 degrees Celsius. But that may be possible if we develop more number of such metal carbonate technique. So there is, suppose, cobalt carbon. So in a cobalt, some definite amount of carbon is deliberately added, because already cobalt, high pure cobalt is within the graphite cell. So your surface carbon will also involve. So Japanese scientists studied it very carefully, and now they have the opportunity that now they can go for this metal carbon technology even up to 3000 degrees Celsius. Many NMIs they have established with our students. We have FEC, COC, and NIC in our laboratory, and already we have um, some infrastructure available for PDC. But lots of infrastructure is required. If you have directly this, the level of uncertainties in radiation pyrometry, which is about 4 degrees Celsius, will become 1.5 or so. And these are increasing for the industrial applications, particularly these crystallization applications, and they are widely used. So this is on fixed point. During melting, it receives, the fixed point receives the latent heat of energy, it remains stable. After it completely melt, it goes to furnace temperature. Again for freezing, it is very stable long plateau that you get. So this corresponding EMF is measured at say copper, so it is 1084 degrees Celsius. So this way we calibrate at different fixed point and generate the interpolation equation. So again, like resistor thermometer, here the difference will be because of the measuring unit, because the voltmeters will have certain electric noises if your AC is putting on and off, or for sensor part it is inhomogeneity, which is very dominating factor, and the drift, because many people in lower range they tend to measure the thermocouple with respect to SPRT. SPRT has a very good uncertainty, but the required uncertainty due to thermocouple need to be taken into account. Although your digital display shows very good values, the background doesn't repeat always. So therefore, with this you can have the traceability for very high temperature. We have the facility up to 1600, and there are still requirements for a very high range. So here the reference junction which you have at ice point need to be always at ice point if you want to have the absolute measurement. If this is in room temperature, which is practically in the site calibrations also, you have to correct this value with respect to the total EMF. So you see the standard table, you go from 0 to say 24 or 25, and you add this EMF there. So as I said, inhomogeneity is very dominating factor. You can see in a very stable furnace, this is you all. So with immersion, there is little deviation, because the thermally migrated electrons from hot zones are coming to cold zone, which is out. Okay, but they are not very linear. You can see in this case it is quite large. So because you see that furnace age, people are not using that very carefully, because they will put the thermometer at 1000 degrees Celsius in a very quick manner. So always you have to take out the thermometer as it is getting cold. Okay, otherwise its properties will quench. You don't know what is happening, but the level of inhomogeneities are quite large, and you never get the reproducible measurements. So reference junction here is very important, and the inhomogeneity of that thermocouple in case of this. Here sensitivity, if you are measuring in EMF, sensitivity will be vary. It depends on the temperature range. Suppose at 100 degrees Celsius, type base thermocouple will have 5 micro volts for 1 degree Celsius. Okay. So there people are not really believing, because at lower temperature, if you miss 1 microvolt, your level of uncertainties are quite large. At very high temperature, maybe it doesn't matter much. But at high temperature, the homogeneity and drifts are very dominating. Yeah, another important area is radiation pyrometers. Okay. So we'll see briefly how we have developed this facility. So the principle is that you have a very highly stable black body, where any external photon coming in the lab, this black body will have several internal reflection, absorption, emission, and at very one point it will exit. Okay, so all that in photons are thermalized to the black body. So they are not a normal room temperature photons. They are now thermalized to the temperature T. So this is given by the amount of energy emitted by the black body is proportional to T power 4, and this sigma was given by Stephen Boltzmann constant. And with this, you can even calculate the emissivities with respect to a standard black body. So by taking the ratio at two different temperature, one temperature where you know the temperature, you know the amount of radiations measured by your pyrometer. In another temperature, maybe temperature is unknown, but you can even measure the amount of radiation calculated. By taking the ratio, you can calculate the unknown temperature. So this is the approach used for fixed point calibration, and depending on the range, this lambda maximum will vary. So at a very low temperature, you are in very IR range. So body temperatures, they are not visible because they are in very IR range. But as you go in high temperature, you start seeing the black body temperature or color after about 660 degrees Celsius. It will start reddish, and about 3000 you are not able to see inside the black body are not allowed. Yeah, you should get the protective glasses because it is UV dominating then. So total radiation thermometers, optical thermometers, spectral radiation thermometers. The difference is only at the spectral. Out of this black body band, you select the wavelength. Okay. So as temperature increases, its intensity will keep on increasing. So that because it is not 100% quantum efficiency for all wavelength that you receive. Okay, so silicon or InGaAs type of filters are used with red wavelength. And for us, for our parameter, it is silicon detector, and we have 650 nanometer. First, it was characterized at PTB with respect to their black bodies, and now we have established this facility at HPL. This kind of black bodies are available in our lab. So at lab we can measure it very accurate way, but these are mostly field level of the instruments. Okay, so whenever you use in a field, the atmosphere becomes very dominating parameter. Maybe in our present case of even clinical thermometer also, people complain at some time because in the winter temperatures are different. In summer, when they measure in the open atmosphere, these temperatures will be quite large. Okay, so if they measure on the sun shining surface, then also there are quite a lot of deviation on the emissivity part. So those need to be taken for account. So there are stringent requirement based on infrared radiation parameters and also for the source. So that need to be accounted for. So these type of sources are now widely available. They are good at higher temperature range. For lower temperature range, they need to have the anti-frost arrangements. So NPL also is looking for a facility because our snow avalanche and other government institutes, they require up to -40, because you know that we have very long Himalayan regions, and now with this, as sir has told, with the increased environmental conditions, very sorry, um, snow avalanches are happening, and our soldiers and facilities are affected. So we are putting the facility there. So size of source effect, because there we need to see, because these sensors are not in contact with the object. Okay, they are not in thermal equilibrium with the object. They are photonic thermometers. So we need to see directly within the surface of the measurement unit, and we should not go away. So there is a stated distance, at what target distance we have to measure. That is given in your parameter. You have to carefully obey. Such a kind of detectors are placed here. So they need to be characterized for temperature dependency and other affected parameters. This is for thermal imager. Industrially, they were using, and they are very robust. But for clinical applications, because for screening, it is okay. But for diagnostic levels, we need to characterize it more. Many NMIs are focusing on AI technologies and defining which is the accurate method to use. And there are international standards also. I think we also have Indian standards also. These techniques are now being extended for diabetic ulceration, because before the ulceration is formed, there is some itching and internal temperature is rise. Okay, if you detect 5 or 6 months before, this patient can be treated, and otherwise, you know that unfortunate situation is you have to amputate the leg or even hands. So we are now becoming diabetic dominating population, and those all techniques need to be employed for such applications. So there, the new parameter will be emissivity and size of source, means as what different distance you have measured. So these are the new parameters that you need to take care while you are doing radiation pyrometry. So we thank legal metrology really. We could focus more on these clinical thermometer parameters, even for contact as well as radiation thermometry. These are the underlying standards and the given permissible limits. So we have to stick to that, and we have to avoid the false acceptance, false rejection. So we have established the required facility. Even they have kindly offered us the sorry, this is old slide, I think. So we have established this clinical thermometer facility at Varanasi as well as in the Ahmedabad. So this project is complete. Let us see we can extend this further. So these are the measurement uncertainty parameters that we have to critically take into account. Although the acceptance criteria is 0.3 degrees Celsius, say in case of LIGT, if you have the plus minus 0.1 as a acceptance criteria, the source level uncertainty should be below 0.03. So 3 times, quite large, better than what we are looking for. Similarly, for IR thermometer black body, it was required less than 0.07. And with lots of effort in during the first phase of COVID, we could establish this up to even 0.05 and critically revolved. Ashutosh sir also has given quite good inputs, and we could serve I think more than 75 models we could measure at CSR NPL. So such a critical cavity black body was required. It is kept in a very high stable path, 0.005, and the thermometer was calibrated on a fixed point. So all this constituted this radiation black body was properly characterized. So all this could used because this was for the climatic condition changes. So our primary standard of humidity was used directly for this purpose. So all focus was on this work, and as you can see several models and how they are characterized in the climatic chamber. So this facility we have developed. As you see, at different location, people tends to afraid and they don't show forehead or proper location. So we made a survey and we found that forehead and wrist is very accurate, because here also in the wrist we have the blood circulation, and there the cross contamination possibilities reduced compared to forehead measurement. Okay, so this type of measurements also certified and by our students, and the confidence level we found is more than 95, and we are evolving this data for some publication. So now we are focused on developing this thermal imager facility. CSR has kindly supported us for testing project, and with this standard requirement, we are now establishing. We have also approached legal, this APMP, and all APMP nations have agreed to have the international intercomparison for this key parameter, so that this is majorly used for the large public place. Okay, and with AI now, the people are also using simultaneously the normal image as well as thermographic image, and it has lots of potential in our defense applications also. So we can certify those all kind of properties. Many time you might come with the requirement for calibration of furnace, chamber and bath from the different user. So there are different protocols given. Suppose if you want to measure the furnace stability and uniformity, so you displace the thermometer from the center to this side, and again from center to this side. This type of stable plateau you will get between say middle 60 or 85% zone, and there you measure the stability and uniformity. Always put your standard and use in that range only, never at the edge locations where you have the losses. Okay, so similarly for the furnaces you can also use this AB or BA level of strategies. For bath, depending on the height, you can measure at 9 locations, 3 at the bottom, middle, and top, and you can evolve the uniformity basically, and middle point will give you the stability. For the chambers, you need to also have the 9 position, which is for say one at center and others at corner. But for large storages, even the areas are very wide. So there are some EN and other standards where you can use 21 and more thermometers at different locations. Last year we have certified. Now in the vicinity of us, we have world's largest seed storage facility, gene bank for the seeds, and it is maintained by some foreign firm. But our institute asked to validate that, and we could do that validation. It is a full room, full chamber, and from quite a lot of years, the seeds are being stored there because they are live seeds. Okay, so and whatever all calamities are increasing, we need to have our own resources and see the environmental changes, how this dynamics is affecting the food growth. Okay. And for that, humidity is one of the important parameter for all kind of food or agricultural industries. For these pharma industries, if they make the capsule and pack it, they pack at very specific conditions and then they arrive at the expiry dates. Okay, so for very hygroscopic salt, they need to go at very low RH, and their dew point will be even -90. Even the thermometers, you see, most of the time there is a blackout, and this is because of the large uh, this transformers. Okay, they get moisture, and there is a very high electrical breakdown. So all those need to be characterized. So basically, humidity is the amount of water vapors present in the air, and when we say that it is moisture, so it is the amount of water vapors in a solid or liquid. So in a air, we have more. Then you can decide this RH to dew point meter, and you can measure the frost and dew. So this is our facility from -30 to 60 for dew and frost. So here only the temperature dependence is very crucial. Other parameters can be manageable. So you need to have the temperature controlled humidity generator. So with this facility, we are serving a very apex level work. The original constitution of India is calligraphed handwritten copies. So these are material, and the outer parts are leather, and it need to be preserved. This new parliament, they are going to have some constitution gallery, and we are working on this. But already from 1994, NPL has established this facility at Parliament Library, and this is maintained at a particular temperature and humidity. Okay, so this is one of the humidity generator developed by NPL is being used for maintaining this facility. So the moisture, we are agricultural economy. We now grow lots of agriculture products and food products. They need to be stored. Okay, so we need to store at that very stated conditions, and it depends on the temperature, pressure, mass. So it is traceable with all these parameters. And because moisture is the crystallized H2O molecules associated with the interior part of the grains or substance, then that is the bound water condition, and there are free water molecules on the surface. So what level of uncertainties and level of characterization that we are looking for is very dependent. FSSI and other several bodies are looking even at times directly. Collectors from some state arrived here, and they were very concerned about the moisture in cotton, because morning at the government center moisture level was different. When they go to ginning in the afternoon, they measure in a very different way, and farmers suicides and many nervous cases happen. So there also we need to contribute. And this is area is also very open for making the Bharatiya Nirdeshak Dravyas. Okay, because these are live seeds, we cannot store longer. at higher moisture content or at lower moisture content they will break. So it is initial mass minus final mass divided by total mass, so total weight. So it is based on that. So you need to have a very high stable oven or integrated oven like this we have. So we have to remain traceable with temperature as well as mass standard has characterized this with mass, and with this we have validated. We have also taken part in international comparison where Korea was NMI of Korea was the pilot, and we could do wood samples and some food grain samples, and with this we have standardized. So there are several parameters that we need to take, and there are several parties are now coming up. Enable is also willing to have this scope for the users, and sir is also thinking whether it is legal parameter. So it will it will be decided in a due course, and then we'll support our services to various kind of users. Okay, in the field there are in thousands of number. Okay, you see the advertisement. Soybean will be accepted only from say 11 to 13%. 11 to 13 is just 2% RH. Okay, so farmers are not so aware about this. So we need to have these facilities, trainings. Okay. For liquid also we have something called Carl Fisher. There is a titrator, and amount of water molecules dissociated is H plus and OH minus, and the corresponding current colorimetry is used. So that also facility we have established. So I think I am in time. So I summarize that whenever we are focusing on calibration for temperature, humidity, or moisture, we need following things. Okay, again we recaptured this. So we need a reference thermometer, which need to be very very carefully chosen. Okay, so calibration of that thermometer, if it is performed on ITS 90 fixed point, then definitely you get 1 millik to 10 millik level of uncertainty in this temperature range. If you do the same by comparison calibration, you go for say 10 millik to 60 millik. So depending on the level, it will affect the level of uncertainties. So target what you are looking for, and based on that you choose the method. Method selection is also very very important. Then noble metal thermocouples, always use noble metal thermocouple if you are using thermocouple as a reference, because reference these base metal thermocouples are not very reproducible. They are cheap, their sensitivity is wide, larger, so you can use little poor indicator. Suppose copper constituent or K type will have 34 microvolts at 1200 degrees Celsius, while type S has only 12 microvolt change. Okay, so but the 12 microvolt change device is quite reproducible because it is noble metal thermocouple. It has no or almost less contamination effects. But base metal always get the oxidation problems and other alloying problems. So there, if you calibrate on ITS 90 fixed point, then uncertainty will be 0.4 to 1.5 degrees. For environmental parameters and many other reference lab also, we have to define RH at a definite temperature. Okay, because it is dependent on temperature. And whenever we seek for the temperature calibration for air temperature also, then it should be defined at what RH it is measured. Okay, so you need to take care. We have to inform the lab at what temperature you are reading RH and what temperature you are using. So if you see the Times of India, yesterday it says Friday, Delhi feels 52 degrees Celsius. So these all become because of the temperature and RH combination or thermal comfort that people now this tourist and other places declare. So it is based on these combinations. So for liquid thermal sources, because you need to invest quite good, very cautiously. Liquid temperature baths are available from -80 to 300. So stability, you have to look for uniformity, axial as well as radial, and critical volume is required to get a very high stability. So don't compromise or go for a narrow short ones. Then furnace calibrators, equalizer blocks, easily you can get now stability 0.1, like good suppliers even you can go in millikelvins also, but you need to, if you are certifying, then you have to get careful about these black bodies. There also stability, uniformity and emissivity correction is very required. You get the certificate for at what emissivity it is working, and whether it is changing with temperature or any other parameter. So like that, humidity generators, these two pressure one temperature or two pressure two temperature, these primary standards are of 1.5 crore facilities. So maybe all people will. Okay, it should cover all the range, and you should be able to convert from that EMF uncertainty to degree Celsius uncertainty. Similarly, drip sensitivity, environmental factors need to be carefully assessed. Direct temperature indicator, if you are using directly temperature, which is becoming little poor, because when we measure direct property resistance or EMF, your level of uncertainties are very good. When you are converting further, your level of uncertainties will increase. Okay, so you need to characterize them from electrical section, and if you have the coefficients available from the prior calibration, you have to put, or you have to put after the present calibration, then you can read very accurately. Okay, so examination is very important when you receive. So examine the sensors and indicator and its working condition at the time of receiving only. Examine the operating temperature, because sometimes you say that it is working up to 660, and in practical it is not, because they don't know, or if they have open, then they will be condensed with moisture, and resistance will start decreasing as condensation. Hello, sir.
Yes, sir. Yes, sir. Your signal was breaking in between.
Sorry, maybe some internet issue.
Yes, sir. Yes, sir. Yes, sir. Please, sir. Please continue. Please continue. Please continue. But yeah, I think again it is disconnected. Sir, are you here? Dr. Shogun, sir? Yes, sir. Please, sir. Please, please continue.
Yes, sir. Now is okay.
Oh, yeah, it is okay, sir. It is okay. Please continue.
Okay, sir. So I think I have completed, but I don't know where was the problem started.
No problem, sir. No problem, sir. You just conclude in the last one slide or last two slides.
Okay, last slide.
Last two slides, sir, please.
Okay. So if they have some questions, we can take questions.
Yes, sir. We will immediately take after these. Are you repeating two slides, sir? Of the last two slides, which we could not hear.
Many participants, I see the red mark.
Yes, sir. Yes, sir. We have received two questions,
Able
sir.
to reach to them, or
No, sir. Actually, we have received two questions. The first question is how to calculate self-heating error in RTDs.
sorry,
Sir, the first question is how to calculate. Are you able to hear me, sir?
I'm not able to listen.
Just a minute, sir. Just a minute. Just a minute. Using this microphone. Now you are able to hear, sir?
A little bit, it is cutting.
Sir, the question is how to calculate self-heating error in RTDs.
Hello.
Yes, sir. Yes, sir. Is it audible, sir? Am I audible?
Yes, sir.
Acha, I think there is some problem with Professor Shivagun speaker. He is not able to hear us.
If I am audible, I think one
Yes, you
person
are
has
audible,
asked
sir.
for
Sir, you are audible.
accessing of RTD calibration.
Yes, sir. Yes, sir.
Okay, I will send to Ashutosh, sir.
Okay.
Okay, then I read. Yeah, only one question there. Hello.
Sir.
I'm trying to join from mobile, but it's also not. Hello.
Yes, sir. Yes, sir. Please,
So
please continue, sir.
shall I connect again?
Please, please, sir. You are connected. You are connected, sir.
I'll try to connect again. I think.
Santoshi, can you give me the sharing rights? Santoshi, can you give me the sharing rights, please? Santoshi? Audible? I think there's some problem with the Dr. Shivagun internet, and I think he's not able to connect us. But as soon as he will be in contact with us, we will ask the questions. We have received two questions. One is how to calculate self-heating error, and second is how to calculate in homogeneity in TCs. I'm very sorry. I'm also not expert of these two topics of these two subjects, so I'm not able to reply these questions right now. But certainly in the group we will reply very soon, within a day or two, or in the mails we will reply these two questions after taking the reply from NPL, National Physical Laboratory. In the meantime, see, basically, as we are all aware, in the legal metrology, we are also concerned about the calibration and testing of thermometers, whether it is mercury, whether it is digital or it is infrared thermometers. Basically, as far as this mercury thermometer, I think that we are very few mercury thermometers are now available. Very few. Okay. I have seen one another question. Certainly, we will reply that question also. So what I was saying that as far as this this mercury thermometer is concerned, I observe that nowadays slowly these mercury thermometers are going away. Now we are not having more large number of manufacturers who are manufacturing these mercury thermometers because it is hazardous, and we are not trying to have these these mercury thermometers. But as far as digital thermometers are concerned, we are having large number of digital thermometers available in the country. They are being manufactured in India, as well as some a large number of quantity is also imported from outside the country, maybe from other nearby countries. So we have to see whether the thermometers which are imported in the country, they are correct or not. What I observed during this COVID time, whether it was thermometer, whether it was pulse oximeter, we have observed that it was not working well. So as far as these, I'm sorry for this interruption. Actually, as far as these digital thermometers are concerned, we have to be very careful because a lot of things are being decided by these thermometers during this COVID time, even after that. And at the same time, infrared thermometers. We have a large number of complaints received on these digital and the infrared thermometers that these thermometers are not giving the correct observations. Maybe that we are not expert or we are not able to check properly how to take the observations from a thermometer, and due to which the different thermometer is giving different readings. But at the same time, we should also understand whether the standard, whether the equipment is correct or not. And what we observe that these equipments are neither verified nor tested nor calibrated, so they are just entering into the country. They are just, and India is becoming a dumping ground for all these type of equipments. So my request to all the manufacturers and the importers to kindly get it verified. The verification fee is very less. It is just 50 paisa per thermometer. So it is nothing actually. I request you that all the manufacturers and all the importers, even the users also, or the sellers also, if you wish to take our facility, we have the facilities at all the regional reference standards laboratories. You can submit your equipments and with the verification fees without GST, and we will give you the calibration certificate or the verification certificate as per your requirement, which will be certainly good for the consumers, for the public, which is actually, and the doctors who are, or the medical practitioners who are actually using it, and on the basis of these equipments, they are deciding, they're prescribing the medicines and other course of action. So my request is, during this COVID time, we have faced this a big problem, and I have received many complaints regarding it, that these thermometers are not okay. My request to all, kindly try to make or try to have a good equipment, standard equipment. At least the reading should be within the permissible limit. If it is beyond the permissible limit, it is useless. And as far as mercury thermometers are concerned, I'm very happy to say that, even because I am having the charge of regional reference standards laboratory in Ahmedabad, I have seen I have the mercury thermometers of about 20, 30 years or 40 years old mercury thermometers, which are having the least count of 0.01 degrees Celsius. I'm telling 0.01. Even in the digital thermometers, to get a 0.01 degrees Celsius the least count or the readability is not very easy. We don't get all type of digital thermometers which have 0.01 degrees Celsius readability. But in my laboratory, I have 0.01 mercury thermometer. So that means we were having very good facility earlier, and we were having very good equipments also. But I think with the passage of time, in place of increasing our standard, somewhere we are basically concerning on the only on the price, and we are losing our standards quality products. I hope that we, being in India, we know, we understand what is the standards, what is the quality, and I think, I hope, I request to all, kindly try to make the good quality equipment. And if you feel at any point of time that this needs to be calibrated, this needs to be tested, we have very good facilities, not only at regional, at the legal metrology, but at the other organizations also. Even National Physical Laboratory, our mother laboratory, is also having all type of facilities which we can take, which we can utilize at any point of time. So these are the very few points which I wanted to share with you. Santosh ji, मेरा sharing नहीं आ रहा है. I'm not able to share.
Sir, this is Dr. Shivagan. I have joined.
Yeah, I know. Sir, are you able to hear us?
Yeah, I am able to hear.
Sir, please speak, sir. Sir, there are two questions. Are you able to hear me, sir, what I am saying? Are you able to hear me, sir? Dr. Shivagun, sir. Dr. Shivagun? I think again there is some problem in his mic. Dr. Shivagun, sir, are you able to hear me? We are not able to hear you. Yes. So basically, when we talk about this legal metrology, and this legal metrology, which is very important for the point of view of security and accuracy of the measurements, we have to understand that these equipments which we are using in India, whether for the medical practitioner, for the transaction or the protection, we are only cover transaction and protection. So these equipments should be correct, and we are here to support the industry. We are here to help the industry wherever you need. If you need in your manufacturing equipments, if you need our help, how to support, we are 100% at any point of time, at all the day, we are available. We are ready to help you, but equipment should be good, product should be very good quality, which not only can be used in India, but it should always be an export quality. My request is, whenever you are manufacturing anything, it should always be an export quality product. Then you will find that yes, certainly we are our standards are being developed. But why we started, why this legal metrology has taken this initiative to start these type of programs, these type of trainings, these type of workshop, to just have a standard in the country. There's nothing else to be because you people are also utilizing, or I should say, even investing your time for these type of workshops. This is only for the development or the standards in the country. Sir, Dr. Shivagun sir, are you able to hear me? Yes, because what I am saying, why I'm just discussing some of the few points of the legal methodology. As we are all aware, this legal methodology is nothing. It is basically, we are talking about the legal requirements to measurements and measuring equipments, all type of measurements what we are doing, taking, all type of weighing which we are doing, or measuring instruments, which is basically to ensure from the public, from the guarantee, from it gives the guarantee, it ensures the public guarantee from the point of view of security and accuracy of measurements and weighments. If we are doing any of these, we are using any equipment which is not correct, so this is our responsibility to seize that equipment. This is our responsibility to stop this equipment in the market immediately, which maybe that up to some extent we are not able to fulfill our responsibility, and that's why these type of equipments are available in the country or in the market. And certainly we are failed somewhere, and we have to take, we are also very, we are taking it very seriously, that what are the equipment which are not correct, how to stop it, how to stop their selling in the market, how to take them back, how to recall them. These type of all type of activities we are planning, and we are issuing even the notices to the manufacturers and the importers, that how these type of equipments are available in the market. Even we have issued some notices for selling weighing and measuring instruments without verification, without licenses, without complying all the requirements of the law, and we are taking all actions as per the law. Actually, the legal methodology is to build confidence in trade, industry, and consumer. Consumers should know that when I'm buying a product, I'm buying a thermometer, I'm buying a weighing machine, I'm buying a product from the market, it is correct. And after sitting over here, I can give you a guarantee that 99% is correct. But we have to take this 1%, and we have to reduce this 1% into 0.00 something percent, so that this is the development, or this is the standardization which we are thinking, which we are actually targeting. We basically, the purpose is to create harmonious environment for conducting businesses. Because see, if one particular manufacturer or the importer is selling its products which are not quality products, obviously there will be a difference in the price, and there will be a lot of other things which we have to consider, that the products should be standard products. Basically, the legal methodology is having its constitutional background from under entry 50 of the union list, and entry 33A from the concurrent list, which talk about the responsibilities of the center as well as of the state governments. This Legal Metrology Act, which basically came into force from 1st of April. Earlier, we were having the very wonderfully drafted Standards of Weights and Measures Act 1976 and the Standards of Weights and Measures Enforcement Act 1985. Now, these two acts were repealed, and from 1st of April 2011, we were having this beautifully very small, very simple act, which is we call Legal Metrology Act. Everybody was aware about this, and the old people who are working, who have worked like we people who have worked under the old act, they know what is the basic difference between these two and what best or what good things have been taken care of in the new act. Basically, the objective of this Legal Metrology Act is to establish and enforce standards of weights and measures. Since morning I'm talking about the standardization of the weighing and measuring part, standardization of this weighing and measuring equipments, and to regulate trade and commerce in weights and measures and other goods which are sold or distributed by weight, measure, or number. We are having large number of NABL laboratories in the country which are actually calibrating these thermometers, blood pressure meters, or other type of weighing and measuring instruments. My request to all the laboratories: kindly don't issue only a piece of paper. Please try to calibrate. At least some readings, some observations are very much required. Then only you will be in a position to say, yes, this equipment is correct or not. We are working under the Department of Consumer Affairs. Basically, this Legal Metrology Act is a very simple act which has only 57 sections. Under this act, the penal provisions have been enhanced to safeguard the interest of consumer. We are aware that standardization of units of weights and measures are now based on metric system, as India is a metric convention country. We have signed the metric convention in 1957, and after that we are the forefathers, the old parliamentarians, they were aware of that in the coming time we need only one type of units which are internationally accepted, and these are the SI system of units: meter, kilogram, and seconds. We also cover the prepackaged commodities. What are the prepackaged commodities? What are the declarations required on the prepackaged commodities? Because with the passage of time, more and more products are now being sold through the prepackaged commodities. So we are aware of that what type of requirements we have to comply on a prepackaged commodity. Certainly, all type of weighing and measuring instruments, whether they are imported or manufactured in India, needs an approval of the director of the legal metrology from the government of India. So to just ensure that this product is correct. There is a prohibition on manufacturing, selling, or repairing of a weight or measure if you don't have the license issued by the state governments. Verification and stamping is also very much required before putting a weighing or measuring instrument into use. And there are some very good provisions have been made for the industry point of view, that they can nominate one director who will be responsible for the provisions or the offenses of the legal metrology if something happens, and the compounding will be done with that director and the company only, not with the all directors. Earlier there was a provision that all the directors were used to be booked, and the penalty was very high because it has to be multiplied with all the directors. We have also have a provision for verification by the private partners. We have the provision of government approved test centers in the new act, and we are thinking that how we can take the help of private laboratories available in the country in the large number, how they can come together with the government and they can verify and calibrate the large number of weighing and measuring instruments which are available in India. And this number is regularly increasing. Earlier, about 10 years back, 20 years back, 30 years back, 40 years back, the equipments are not of that number as we have today. And it is going to be very difficult even for the state government officers. They have an army of their repairers with them. Even after it is becoming very difficult, and a lot of other type of problems are happening regularly, which we have to resolve, and which we have to basically address. Accordingly, this provision of government approved test center was made in the Legal Metrology Act. As far as legal metrology is concerned, we only concern about the protection and transaction. What is the meaning of protection? If we talk where the legal metrology will come into the picture, protection means utilization of any reading obtained from any weight or measure for the purpose of determining any step which is required to be taken to safeguard the well-being of any human being, or for the well-being of any human being or animal, or to protect any commodity, vegetation, or thing, whether individually or collectively. So any weighing or measuring instrument which the readings taken from that equipment, if will be used for the well-being of any human, animal, or vegetation, or a thing, this equipment will cover under the Legal Metrology Act. So whether we are any type of medical equipment or any type of medical device, medical measurement which we are taking, which we are doing, whether it is EEG machine, whether it is ECG machine, these all cover under the legal metrology. Actually, we are not doing all type of weighing and measuring instrument, but still these have to be covered slowly, so that we have a very good regulated standard in the country. Similarly, if we talk about the transaction covers all type of contract, whether for sale, purchase, exchange, or for any other purpose, or any assessment of royalty, toll, duty, or other dues, or for the assessment of any work done, wages due, or services rendered. So basically, it covers the whole picture of the transaction and the protection. We should be very clear that transaction means any type of transaction which we are doing, and protection means for any equipment which is used for which are the readings of that equipment, if they are used for the protection of any commodity, any human being or an animal, they are covered under the legal methodology. We are happy to say that we are the international organization member, legal methodology member country, and Director of Legal Metrology, Government of India, Shri Bhin Dikshit Sahab is the CML member who represents India in the CML meetings of the OML. And as soon as and when happens, and I remember that every month we have at least 2-3 meetings. Nowadays, it is very good that we have the online meetings, and we are able to participate in all the meetings whatsoever is happening internationally, and we used to participate. We used to vote whether it is electronic vehicle charging meeting, which was happened just a few days back, in which we have also voted that yes, it is very much required, which for the betterment of for the measurement of the electricity, for the measurement of the battery charging, how much we are paying and how much it is being done. So all these things are regularly happening, and it is very good that India signed this OML convention before signing the meter convention. We became the member of OML in 1956, immediately after 1 year when in 1955, when this OML was formed. It is an intergovernmental organization. Basically, governments had formed it, and the Honorable President of India at that time, Dr. Rajendra Prasad, has signed that convention internationally. And then we have basically right now we have about 62 member states and 63 corresponding member states. India is a member state, and India signed meter convention in 1957, and that's why we have this international prototype of mass and other parameters as other SI units, which are 57, K57. This OML is basically to promote the global harmonization of legal methodology. What I say that we should manufacture a product which can be exported. Why it is so? Because if a product which is being manufactured in India and it is approved in India right now, what approval we are giving, this approval is for India only. We don't say that it should be accepted all over the world, but very soon we are in a position to have an international recognition of our certificates issued by Government of India, so that our manufacturers can sell these equipments outside the country. But at the same time, I would like to say that till right now, many of the manufacturers, many of the weighing and measuring instruments manufacturers are selling their products, exporting their products in the other countries, and the approval certificates issued by the Government of India is being accepted in many of the countries, even after OS. But the OML standards, we are not basically saying that we are the OML issuing authority. However, these certificates are accepted, and wherever some information is being asked from us, whether the certificate is okay or not, and this testing is okay or not, we used to say yes, it is okay, because whatsoever the testing we are doing in India, these are all as per OIML standards. We are not doing anything, any testing which is not as per OML specifications or the OML standards. And basically, the purpose of this global harmonization is to harmonize national laws and regulations on performance of measuring equipments, facilitate international commerce of measuring instruments and affected products, ensure quality measurements for public and worker health and safety, and protection of environment. It is very important. Basically, we have the quality measurements, but if we are not doing the measurements, if you are not taking any measurements, then how this quality measurements will come to the picture? So my request is quality will come later. First, we have to start doing the measurements. And I tell you, I remember about 20-30 years back when we were actually doing the calibration, we were actually doing the measurements. Nowadays, with the passage of time, we have just taken a new change that we need a piece of paper, nothing else. My request is don't go towards the piece of paper. Think about the quality measurements. And I tell you, until unless in a country, if we are not doing the testing, we are not doing the calibration, we can never be a developed country. If you want to be a developed country, you have the standards in your daily life. You have to do the calibration, you have to do the testing. Even at some level, if we find that we are doing wrong, certainly we are always ready to take the steps. What's better, good steps we have to take in the legal methodology. Seeing is also we are doing this OML. This OML is doing for the harmonization of national procedures for testing and verifying the performance of measuring instruments, as we have all the rules made under the Legal Metrology Act. If we are talking about the benefits of harmonization, basically it increased the international trade. The purpose is only the international trade. It reduced the cost for manufacturing, and it also produce the quality products, for the measurements of society. Basically, it impacts not only the consumer, it impacts the national and international trade, it impacts the industries. And basically, we have all, as I already told you, that we are participating in the OML meetings. We are the member of almost all the technical and the administrative committees of OML. We used to vote and submit our comments time to time whenever they are asked. We have also got trained our legal methodology officers at different countries, Japan, China, Cambodia, etc. We are having the members in OML certification system, which I was talking that we are not issuing the OML certificates, even after we were the member of all these committees of OMLCS. And we are also having the OML experts from India. The new technologies which we are talking about are the electric vehicle charging, hydrogen cars, LNG trucks, gas meters, energy meter, moisture meter. Yes, moisture meter is also very important. I don't think that we are doing the proper calibration or the testing of these moisture meters, but certainly they plays a very important role when we talk about the agri being an agri, as sir has already told, we are an agricultural country, so we have to understand all these things. Sound level meters, taxis using GPS, radar equipment for speed of vehicles, EEG, ECG, etc. So basically, this new technology or this OML or these rules or these equipments are playing very important role at the time of sale. We need documents, we need standards, we need methods, we need training. So all these type of slowly we are working on it, and I hope that very soon we will be in a position to get all these things in place. Right now we are having we have developed a lot since last 10-20 years. If I observe, I feel that now all the weighing and measuring instruments or the laboratories in the state government are very good. They are all equipped with all new equipments. They are the officers working in the laboratories are technically sound, technically trained. Even after we are trying our best, and I always used to request our industry people to kindly educate us wherever you know better, because I know you know better than us, because you are manufacturing a product. If I am testing a product, it is just one part of that 100 parts which you are doing in manufacturing a product. So you know better than us. Kindly educate us what else is required. We will certainly we will learn, and we'll try to do better, or simply to just offer our better facilities to the society. Basically, we have all type of controls. One is model approval, second is initial verification, and then the subsequent verifications which are required under the law. And if we are not doing, then it is a violation of law, and certainly there is a provision under the law to take action against them. If you're talking about this regional laboratories, we are now, as we are all aware, we have right now 6 regional reference standards laboratories which are working at Ahmedabad, Bangalore, Bhubaneswar, Faridabad, Guwahati, and Varanasi. One another new laboratory which is at Nagpur is just coming up, but I hope that these laboratories are working well and having all the facilities more or less they are similar, and we are trying to help the industry and the consumer in the field of legal metrology. Basically, these RSL's work serves as a link between the National Physical Laboratory and the state's legal metrology departments laboratories to ensure correct weighment and measurement in trade and transaction. We maintain reference standards for verification of legal standards of states. Basically, our standards are in between the state government laboratories and the National Physical Laboratory, which is a mother laboratory in India, NMI. RSL Ahmedabad is working since 1977, and we have all type of facility. We are NABL accredited lab. We have also this BIS. We have also BIS accredited, BIS empaneled laboratory in Ahmedabad. So these are the basic functions which we are performing. We are also organizing training programs, etc., as we are doing today, called this type of workshops. This is our purpose, to organize regularly. If we talk about the testing facilities, as per this general rules, OML standards, or say ISO, IC, or BIS standards, we have all type of non-automatic weighing instruments facility, including weigh bridges. We have automatic weighing instruments, automatic gravimetric, hopper weigher, belt weigher, weighing motion, road weigh bridges, railway bridges, etc. We also have the facility for dispensing units, petrol, diesel, LNG, CNG, etc., LPG, etc. We have facility for liquor measures. We have facility for flow meters. We have very good facility for flow meters in our laboratory. Even now, earlier we were using the master mass flow meters in our laboratory. We have simply converted it from these mass flow meters. With the facility of mass flow meters, we have also developed it's through the weight only, because weight is ultimate unit, and we have developed the facility to get these flow meters calibrated and tested with the help of weighing facility. We are also having the water meter facility, very good water meter facility. Developed these flow meters and the water meters facilities were developed by FCRI, Fluid Control Research Institute, which is one of the very good institute in India. Thermometers, spine move manometers, length measures, taximeters, etc. These thermometers and spine move manometers and length measures facilities were developed by National Physical Laboratory, which is our mother laboratory. We are also having the ISO IC standards for discharge test, bus test, voltage interruption test, anemometer test, etc. As per the BIS standards, we have the facility for this. Even for mass, we have all type of facilities from 1 milligram to 200 gram for even and E2 class weight, and from 1 milligram to 1200 kg of all other types of weights from F1 to M3. We have also the facility for calibration and testing of non-automatic weighing instruments, which including weigh bridges from 2 gram to 200 ton. We have all these very good equipments available with us. And we have for volume parameters also all type of volume measurements as per BIS standards we are doing. We also have the dimensional measurements, 1 year, etc. as per the BIS standards. We also have this length measures, which of the order of 5 micron. It is up to 100 meter we can calibrate, and we can test as per the requirement of the legal metrology or the enabled laboratories. We have this equipment of accuracy 5 micrometer, and it is very good working, very well working. We have hydrometer facilities also. We have thermometer. These are the equipments which we are having since last maybe more than 20 years. And now we have also developed a very good new facility given by the National Physical Laboratory, installed by the National Physical Laboratory. This facility is actually extremely good, and I'm very happy. I'm very thankful to National Physical Laboratory for extending their help and support all the time whenever we are requesting. Even on Saturdays and Sundays when they can work, they can come with us to help the industry, to help the country. Certainly, they are very good people and very good, very knowledgeable scientists who are working in their fields. We have the facility for pressure gauges, including the BP meter. We have the test sieves calibration facility. We have force. Yes, this force facility, it was also developed by the National Physical Laboratory. We have all the primary also up to 5 kN. We have the primary facility developed by the National Physical Laboratory. All these facilities are being developed by the National Physical Laboratory at all RSL, at all regional reference standards laboratory. And then we have up to 50 kN. We have the compression and tensile mode facility. Torque facility is also being developed by National Physical Laboratory. We have the facility from 0.1 nanometer Newton meter to 1000 Newton meter, and it is working well. This is our flow meter, and now we have developed the weighing also. So up to 100 mm, or even more than that, we can weigh. We can do this calibration or testing with the help of this weighing facility, which has developed recently at our flow meter lab. We have very good flow meter lab. This is the water meter facility, which we have using gravimetric method. We also have the facility for tank calibration. We have the provision of, as I already discussed in the beginning, that we have the provision for government approved test centers, that few private partners, few private laboratories can also help us in doing this calibration of weighing and measuring equipments, verification and stamping of weighing and measuring instruments with the state governments, with the central government. We have power to make the rules. Government has already defined some of the equipments under this list of weighing and measuring instrument, which can be verified by the private partners or by the GATC, government approved test centers. As we are all aware, we have stopped this single-use plastic from 1st of July. My request is to kindly reduce this type of plastic pollution, because it is certainly creating a lot of problem. Secondly, one very important thing which I wanted to share with you is the cybercrime. We have to be very careful, because what we are observing with the last week, we were having this conference on this cybercrime, and we come to know that there are a lot of problems with the cyber, and what type of numbers we have to keep with us, so that we can also save our problems. We can also complain our things. We can also bring the problems or the wrongdoings which happen with us to the authorities, so that the action can be taken at the right time. These all things for the cyber crimes are very important. We have to be careful. We have to consider them, and we have to solve them. Sir, this is a very small thing with a very small brief presentation, which I wanted to share with the participants after a long time. And what are the facilities? If the industry wants to take our help, we are always available. They can help us, or they can simply take our help wherever required. Shivagam Saab, are you able to hear me?
Sir.
Okay, so now I have a few questions. If you kindly reply.
Yes.
Sir, how to calculate self-heating error in RTDs?
Yeah. So this self-heating error is the joule heating developed because of the current that we give to the thermometer. So there is a rule. Mostly we are giving 1 milliamp as a carrier current for 25 or PT100. Then we have to go root 2 times that current. So it is 1.414, and take the difference of the resistance, and that becomes the self-heating. That rise in resistance and corresponding temperature is because of the self-heating.
Okay.
So that we have to subtract from the measured value of R. So
1.4.
R final Because we are measuring resistance,
Yes.
R0, then we have to have the R0 minus delta R.
Okay.
So whatever
Okay.
the current that we get at 1 milliamp, then whatever current we get at 1.4 milliamp, we have to subtract from the observed value.
Good.
So that is self-heating. That is a Joule heating.
Okay. Thank you, sir. So next question is how to calculate uh, in homogeneity in TCs,
Uh, Inhomogeneity.
in homogeneities in trans.
Yeah. So for measurement of inhomogeneity, we need to have a very stable bath or a very stable furnace. Then we have to take that thermometer from bottom of that whatever source to the outer part. Okay.
Okay.
So while we are moving, we can see what is the change in EMF we are observing.
Okay.
And the net difference, maxima minus minima, will
Okay.
give us inhomogeneity.
Okay.
So whenever
Thank you,
we
sir.
take part into intercomparison,
Yes, sir.
this is one of the important parameter. Otherwise, just by looking the display, people
Okay.
think that it should be as equal as accurate as a resistance thermometer. But
Okay.
reproducibility is very problem there. So
Okay.
uncertainties will be 0.4 and higher
Okay.
because of
Thank you,
this.
sir. So next question is how to select distribution in uncertainty.
Yeah. So distribution and uncertainty depends on the experiences, how our measurement is varying with respect to the parameter that we want to vary. Say for example, stability or uniformity. So whatever is the variation in my X, the stability, correspondingly my resistance thermometer is also going to vary. So dy by dx, both magnitude will vary depending on the dx variation, dy will vary. So rectangle distribution is applicable. In very few cases, triangular distribution is applicable, but then we divide by root 6. So the level of confidence should be better. In case of rectangular, it is divided by root 3. So the total value is little no, coarser, so that we remain in the confidence level.
Thank you, sir.
So for all thermal type B, I will advise to use rectangle distribution.
Okay. Okay. Thank you, sir. So next question is, it is good. Primary standards capped at BIPM. How we can say whether it is correct or how we validate it? Sir, we cannot validate. That's why we are now moving towards the natural constants from the artifacts.
Yeah.
Now we are moving towards the natural constants. That's why this has been decided. I think it is okay. Next is why DOF. We generally take n minus 1. Degree of freedom.
Yeah.
We take generally n
Because
minus 1.
it is with the assumption, otherwise other statisticians they take n there, but in
Okay.
our case we take say 10 reading. So the
Okay.
philosophy is that these 10 readings are chosen for infinite stable readings.
Okay.
If we take many readings at the back, if you take many readings of the ahead, it
Okay.
will not deviate. So any out of say 10 reading, one reading is taken out, that mod of x minus x bar becomes non-zero. Okay. So therefore, in case of say type A, it is taken as n minus 1. And in other cases, because it is given from the certificate, then it is 2. And in case of other evaluation, it is taken as infinite. Degree of freedom is infinite. The stability of bath can
Okay,
go
sir.
on
Thank you.
as long as you use.
So next
So
question
that is
is
effectively.
while selecting coverage factor, we choose 95% confidence level. I think it is the same question which you have replied.
Yes.
While selecting coverage factor, we choose 95% confidence level.
Yes, because that is induced because of the, as you said, probability distribution. Which probability distribution is correct? Whether triangular or rectangular. If you take triangular, the total value of that measurement will becomes less. So your uncertainty will be good, but when you go for the quality assurance, maybe you go out. So you remain more confident by becoming little poor. but quality assurance will be validated.
Okay. Sir,
Therefore, the coverage factor
how to
comes into play.
calculate wall radiation in chamber calibration?
Yes, sir. Yes, sir.
How to calculate wall radiation in chamber calibration?
Yes, in chamber calibration, there are two dominating parameters: stability and uniformity. So stability, as I said, at a given location with respect to time, we have some variation. So maxima minus minima divided by 2 will become a stability. But when we take the uniformity, the mean value of the center is subtracted from the each location, and then whatever poorer estimate we get, we refer it to as a uniformity. This is given very well in page number 51 of
Okay.
enable criteria, which is previous criteria 124. So it is very well described then, because many people have this ambiguity. So enable in specific criteria, we come out with the definite example.
Okay.
So from the
Thank you
center
very much,
mean,
sir.
yes, sir.
Please, sir. Please.
Yeah, from the center mean, you have to take the dispersion from at the all locations. So whatever becomes maximum, then that is the taken as the poorest is taken as the estimate for the uniform.
Okay. Thank you very much, sir, with this all your question answers. And if there will be
Thank you,
some more
sir.
questions, I will send it to you, sir. You kindly reply, and we will forward it either through WhatsApp or through mails when we will be issuing the certificate. And we will issue a
Yes.
certificate to all the participants, sir. And sir, now basically my request is, if you kindly allow, we will use your signatures also on the certificates, which will be issued on to the participants.
Yes, yes.
Thank you very much, sir. Thank you.
Thank you
With
so
this, sir,
much,
I
sir.
would like to thank
I
my director, sir.
apologize for the internet problem that I experienced.
No issue, no
Some
issue. It was
maintenance
very
work
good.
is
It
going.
was very good. You had explained very well manner. Sir, my request is once you come to Ahmedabad, because your machine is there, and we will be having a physical training to all the participants, how to calibrate. You will show to all the participants, and how to calculate the uncertainty. You will show practically to give them. So this
Yes,
will
sir,
be a very good
definitely.
one exercise we will do for 2 hours or 4 hours, 2 hours in the morning and 2 hours in the afternoon, so that this whole thermal parameters will be very clear to my most of the industry people, most of the laboratory people. This will be request to you, sir. Now I would like to thank
Certainly,
you
certainly, sir.
and my director, sir, who is here and who is listening all these exercises. Sir, thank you very much. You are always
Thank you, Ashutosh ji.
thank you very much, sir.
Thank
Thank you. Thanks to my NIC team who is working for us on Saturday, Sundays, being holidays, and all the participants who are here to listen us, whether it is of their interest or not. I don't know whether we are able to fulfill their requirements or not, but still we are trying our best. With this, I would like to thank all. Thank you very much. Thank you, sir.
Thank you.
Thank you so much, sir.
Thank you, boss. Thank you, Santosh ji.
मीटिंग क्लोज हो गई
Yes, just closed. Please close कर दीजिए.